Good afternoon, everyone, and welcome to this webinar organized by the Horizon 4 Proteins cluster on sustainability of alternative proteins. Why are we interested in alternative protein sources? Mainly because this is a global challenge, a big challenge. The current protein production needs to be increased because of the growing world population, the climate change, and the pressure on natural resources. And this increase in protein-rich food is not sustainable if based only on conventional animal sources. So there is a lot of research activity in this field. And in 2019, the European Commission funded 4 research projects focused on alternative protein for food and feed. These 4 projects are NextGen Proteins, ProFuture, Smart Protein, and Susin Chain. Here you can find also the link to the web page of these projects. These projects share the same objective, that is the increase of the availability of high-quality alternative proteins from plants, insects, microalgae, microorganisms, and other resources for food and feed applications. So, with the support of the 4 sister projects, the Horizon 4 Protein Cluster was created to share information between the different projects and to organize joint dissemination activities. And this webinar is one of the activities promoted by the Horizon 4 Protein Cluster. In this link, you can find a short video describing more in detail the Horizon 4 Protein Cluster. And this is the agenda for today. After my short introduction, we have planned 2 presentations. From the first from Sergi Smetana and the second one from after Sigurd Johnson. At the end of the presentation, we will have also the possibility, a short time for a question and answer session. Also a short introduction to the speaker. I am a senior researcher at the Institute of Agri-Food Research and Technology in Spain, and I am the scientific coordinator of the ProFuture project. Sergi Smetana is head of the Food Data Group at the German Institute of Food Technologies in Germany. And after Sigurd Johnson is head of the sustainability at KPMG in Iceland.
Thank you for the nice introduction and for very nice introduction topic wise. And I would like to start right away with the presentation. We don't have that much time on the of the Susin Chain project, which I'm going to present today. Of course, from the perspective of the work which we are doing in that project, and what is our insights, what is our view on the future of the proteins, or horizon for the proteins cluster, and what could be our input in the future of the proteins. A couple of words about myself. My name is Sergi Smetana, and I'm head of Food Data Group in German Institute of Food Technologies, and we, as many other partners involved in the project Susin Chain, which is by the name Sustainable Insect Chains, aims to contribute and provide insights for the novel protein provision for feed and food in Europe. And we know that insect industry is being developed in Europe, and there are certain barriers and hurdles, and the whole idea is to find optimal, feasible ways from economic, environmental, social perspective to overcome those and see which role the insect industry can play in the future. And there are some basic facts on this slide presented about the project, and also websites and of course the different links for the distribution and dissemination of the project. And you're welcome to follow us and of course to check on our work and updates, because at the current stage, which been 3 years after the start of the project, currently are coming more or less daily, weekly, monthly right now, because it's already, we have quite some results at this point in time. Why Susin chain, and as well as other projects connected with the novel protein sources actually being established? What's the need? One of the needs which we see is that the whole food system, the current state of the whole food system, is pretty complex and complicated. And it's not just saying, okay, we have one source and it has certain level of proteins and we can consume it, and that will be beneficial for humanity, will be beneficial for human health and for the environment. But already by telling that, I already demonstrate that the system is actually much more complex and includes not only the production chain, but also effects on the human population, connected to the regulations, connected with the environmental conditions, the country regulations, with the policies, with the geographic distribution of the resources. So there is quite a big complex system which we have to take account into. And one of the ways, and it's observed not only from environmental perspective, but also in other areas, is the application of something called life cycle approach. When we're looking from the perspective of the whole production chain, of the whole supply chain, and the whole supply chain and production chain can be, as the one presented on the previous slide, can be quite holistic, quite big. Life cycle approaches or life cycle assessments specifically dealing with environmental impact allows to look at the different impact categories. There are different softwares. There's quite a lot of databases. There's quite a lot of information about the standard products out there, which we can present and analyze in terms of different impact categories, but also in terms of integrated scores, and try to compare those integrated scores or find different trade-offs between environmental part, social and economic as well, and try to make consolidated outcomes, consolidated conclusions about that. And of course, as Susin chain is a project dealing with insects mainly, we have to figure out what is the role for insects as a potential source of the proteins in the future. And this picture, the scheme demonstrates it very nicely. It's something that we see a future for the insect production, which can rely on quite various waste sources or side streams. So some underutilized raw materials or unutilized raw materials, which can be used for the production of insects, and of course can be fed then to animals or to humans, maybe even, and any kind of leftovers, any kind of fertilizers, coming from insect frass can be then fed back to the soils to improve their quality. There are of course certain challenges, which again the whole project is aimed to find solutions for challenges, and one of those could be the challenges associated with assurance of the safety and certain legal perspectives. And one of those is, of course, not all the food waste can be fed into the insects, because insects are considered to be as farmed animals, and certain precautions has been taken. There are regulations, all the regulations apply to the insects the same as to the farmed animals in European Union at least. So, and only certain types of waste or side streams can be utilized as a feed for insects and for their production, which basically sets up another challenge that in many cases, companies, insect producing companies, are picking up the opportunities and saying, okay, we will utilize some materials, some feeds directly from the agriculture, which of course does not improve the environmental benefits and doesn't improve the situation. Moreover, what we would love to have from sustainability point of view is that insects ideally should be utilized directly for the human consumption, even though they are fed on direct waste from the food system. That will be ideal upscaling for the nutrients for insect production. But maybe moving a little bit further, kind of closer to the reality, closer to the real products, we should consider that insect production chains could be utilized for quite a various purposes. One of the most novel ones is the application them as meat substitutes of food products. Again, that will be ideal situation if insects are grown on waste and side streams and then utilized directly to the food. And there's been quite some developments also for the utilization of insects as a part of biomass for the substitution of meat. Or they can be utilized by separate fractions, for example, as a very nice source of fats, and fats of different insects have also quite various purposes. Again, we can separate protein fraction from fat fraction and have quite a consolidated use of those. For example, here in the picture on the left side presented different types of margarine-like fat-based product. I cannot say butter because butter is only produced from the milk. So it's margarine-like spreadable product, which has very similar properties. It has a melting point. It has a very nice, and of course, depending on the combination of fats from different insects, it can provide a very valuable and interesting products out there. And potentially, there's something to think also in the future to substitute the coconut, for example, oil, palm oil, or coconut fat applied in the food industry quite widely. Or then also fat fraction or complete insect juice, so to say, can be utilized also as a milk substitute with certain processing parameters, can have similar homogenized properties, would look similar, would taste also quite similar, and well, taste a little bit differently, but could be quite similar in terms of nutritional properties and in terms of physical properties. And of course, the point that we're talking about all these different products, would it be for feed and food purposes? Would it be absolute product for feed purposes? Is that in many cases we kind of have to create the first prototype. We have to create the new products which we will able to assess, because that's what's being consumed as a product and not just the protein sources as they are. Despite all these different products, of course, the project is relying on quite a lot of modeling and quite a big analysis in terms of environmental hotspots. And of course, I can tell, okay, there are a lot of databases, a lot of data, but maybe a few words on how we get in them. Here on the left represented a very simple production chain when we take raw materials from agriculture directly, and that in many cases defines the environmental impact in terms of greenhouse gases, land use, and water demand. But we can also rely on some waste and side streams, as mentioned before. In this case, for economic allocation, the impact can be reduced twice, or can be also brought up all the way down to zero almost, when we say, okay, we are taking some waste which doesn't bring any environmental burden. Or we can say we even recycle, or we avoid the treatment of the waste products, and by that we get environmentally beneficial products. Another point for insects as animals is that they are characterized with the feed conversion ratio. The lower it is, the better. But depending on the type of the product, would it be main product, would it be byproducts, would it be waste, we could have quite a different feed conversion ratio, and also for different insect species. So it's all varies. In some cases, there's still not a lot of data. Still, data is missing, so some more research is needed. But nevertheless, we can already make certain level of conclusions. Another important point for the insects is, of course, development time. In some cases, it could be very quickly, 13 days, 9 days, but in some cases it requires, 160 days, depending again, or 200 days, depending on the properties of the feed, depending on the feed conversion ratio, depending on the other conditions. At the end, combining all this data and combining all these properties, we are getting the environmental impacts. Again, on greenhouse gases, land occupation, water demand, we can get all these variable amounts of different data, which we can then utilize for the analysis and for the modeling. For example, we can estimate the higher and the lowest rate, for all the insect species, and say, okay, this is the ranges of environmental impacts. or for the land occupation in a similar way. Or we can also define what is the lowest case, the lowest impact case, so the best environmentally case which can be applied, and how it can be integrated, what we can do to promote those cases, and provide certain tricks, certain hints for the policymakers. But when we take in these ranges, we, of course, in many cases, what we do, we are comparing to conventional sources of proteins and seeing, okay, where the insects are standing. And here, the same data presented on the previous slide, calculated per 100 grams of proteins, and compared to the results from the study of Purov Nemechik in 2010, and you can see that insect products in these impact categories, greenhouse gas emissions and land use, can be can have quite wide ranges of environmental impacts, and they are separated here by two blue lines. And you can see in some cases they are even positive, environmentally positive. Of course, these cases are the most interesting ones for us, and that's where we want to hit and target in order to promote and support that insect industry as potentially sustainable source of proteins. But in some cases, when you take slow growing insects and with a poor feed conversion rate, high quality feed sources, commercial feed sources, and so on, then you can get environmental impact as high as of some meat sources, for example. But that's not the end of story. It's only environmental impact. When we talk about sustainability, it's much more complex and complicated issues, and you can see here is a very structured in certain way diagram. So it's presenting also economic, environmental, and social factors with red, green, and blue colors, respectively, but also the black color abbreviations are presented. Those are different aspects which we consider to be quite interesting and influencing the sustainability, and mostly environmental impact, but also economic and social aspects of insect production chains. They all can be characterized with different mathematical models, can be represented with the idea, okay, there could be variations in their production, variations in the different properties of production chains. They can depend on other factors which we want to take into account, because the system is quite complex. And when we take in all these different factors and mathematical models into the consideration, that becomes complex for a normal human being to put together and say, okay, this is the better case than the other one, because in many cases they are conflicting. So that's why we apply more consolidated factors, like for the environmental impact, and we also collect this data, put this data together, and apply something that's called multi-objective optimization. When we collect social and economic environmental data, put in different, apply it to the different models of the production chains, combine them into different scenarios using Brightway as example of the tool, also combining with the data available from other databases and literature sources, with the idea to define the optimal production chains, which might not be the most environmentally friendly or not the most socially acceptable, but they will be optimal from a few factors, and maybe not from all the factors. So currently we defined a few production chains, a few insect value chains, which we will of course communicate in the near future. With this, I would like to come to the concluding points. Of course, insects are great, but it's any novel source of proteins, they have benefits and drawbacks, and their sustainability and their environmental impact specifically defined by the type of feed applied. Would it be commercial feeds? Would it be byproducts of side streams or waste? And it does not automatically mean that application of commercial feed would result into the low environmental performance of the insects. In some cases, it can also get a high quality biomass which can be applied for the better quality uses. The same for the waste. Application of waste does not automatically guarantee the higher environmental performance of getting environmentally beneficial insect species, because they can also be applied for the different purposes, and then you have different benchmarks to compare to. Moreover, the production of insects depend on location, technology, society, resource use. All these different types are influencing feasibility and sustainability of insect production. What is needed? We need more tabletop research, we need more analysis, we need more laboratory and in-field analysis, more data from that, of course, and putting those data in different databases, which should be interchangeable and openly available for further analysis and further use. Of course, I would like to use the opportunity to express my acknowledgements and gratitude to all the Susan chain partners, because without their basic work, without work on different aspects, also sustainability assessment won't be possible. Of course, work package 7 partners who are specifically involved in the life cycle assessment and sustainability assessment of insect production chains, and the food data group of German Institute of Food Technologies, where I actually come in, who those people who actually support it practically and directly. With this, I would like to say thank you for your attention, and hopefully you enjoyed my presentation.
Thank you very much. Thank you very much, Sergio. We are on time, so we have space for a question, if there is some question now. I can see the chat, but no, there is no question. Well, I have a question for you. As you mentioned before, the food system is quite complex. So do you think that the model estimating the environmental impact need further specific adaptation or standardization for the alternative protein sources in comparison with the conventional one?
Yes, actually very complex question. It sounds simple, but it's actually not. And that is true, very true for specifically for novel protein sources, because currently what we see, okay, we can estimate, we can analyze and get certain level of results, but they will be quite specific for the specific type of production here. And if you move it to another country, or if you change some other parts, so we see a lot of changes and results change sometimes very rapidly. So what we think should be done is some kind of normalization, or you can, as you say, standardization of the assessment in terms of standardizing the methodologies which can be used for the assessment, and another point, standardizing certain level of weighting factors for the protein sources, because currently, okay, we can get some carbon footprint and other factors, but what does it actually mean for the production of the proteins in the country, for example? So what we are trying, maybe a little bit inside, what we are trying to also to do and think is to develop weighting factors which will be dependent on the current amount of protein supplies within a region, a country, or production area. I don't know, something to think about, but that would actually reflect the necessity of the proteins in this region, because in some areas maybe there is no additional need for the proteins, you know, starting from that point. And then, okay, if you have also high environmental impact and other factors, maybe it should be given a lower rate, that, you know, it shouldn't be then supplied in these conditions. But in general, yes, we need standardization of assessments, approaches to the assessments, similar what is done in product environmental footprint for the food and feed industry, and also standardization of interpretation, I would say, interpretation of the results. Yes, absolutely.
Okay, this is of course, this is a big point of discussion. Okay, thank you very much again for your presentation. So we can move to the second presentation. After, the floor is yours.
Yes, thank you very much. Everybody can hear me fine?
Yes.
I think it was a very interesting discussion after the talk, and a very interesting presentation by Sergi. And I think standardization in like a sector or topic level is very interesting subject in terms of in life cycle assessment perspective. Maybe you can talk about that a bit more after my talk, which is on alternative proteins and the circular economy like aspects of it. I'm coming from the project NextGen Proteins, and my part there is to analyze the sustainability aspects of 4 different protein producers. So the overall project is like transforming biomass into next generation protein for food or feed. And as I said, there are 4 different case studies that we're looking at: algae production, single cell protein production, and using insects, either black soldier flies or crickets, to produce protein. We have a very specific part in the project, which is to assess the sustainability aspects, the environmental, economic, and social impacts and value chain risk. And we've been doing a fair share analysis, analyzing the inputs and outputs of the processes themselves and doing life cycle assessment, which is still continuing, but we have been assessing the circular economy potential of these protein producers based on the input and outputs values and the sources that are required for the production. And then we will ultimately perform a multi-criteria value chain assessment. But of course, our part is also to try to communicate these different aspects outside of the project and try to talk about them clearly and effectively, and this is part of that process. So if just, I think Sergi and Massimo talked very well about the reasons for doing these kind of projects in the EU, but I just wanted to sum up a bit. Like, of course, sustainability is a concept that is very much on the agenda from various perspectives, but it's talked about in various different ways. Sustainability in general is trying to maintain something for a lengthy period without interruptions or weakening. And sustainable development can be defined as a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. Quite recently, the sustainability concept has been entered into the commercial world, where it's looked at from various different angles, and I think it's important to have those included when you talk about sustainability for example, new production of a product that needs to be sustainable from a few perspectives. Of course, the companies need to be profitable in the end with good principle of governance, but while protecting social and environmental balance. And that balance is the most important part of our job in the project. If we think about the environmental balance, we can take a look at a few different environmental studies, but I think what captures it quite well is the planetary boundaries analysis and dissemination of the results of the human impact on the planet. And as you can see here, there are of course red or concerns in biodiversity loss, climate change, nitrogen cycles, and land use and stuff like that. Very much a lot of this is because of resource use and a lot because of our food needs and food production methods today. But of course, we need to sustain a social balance. We need food and we need water and energy to sustain ourselves. And there is some kind of I think of a social foundation which we need to fit into. And I think this is very, very good way to capture sustainability, is that we need to find a way to live and operate within the sustainable or below or above the social foundation and below the ecological ceiling for a just and environmentally friendly world. So I think that humanity's 21st century challenge is to meet those demands for the planet. And circular economy has a large role there. We of course live in a linear economy where we use resources and we produce food or different stuff for us to use, which we waste in the end. A circular economy is more regenerative. We try to use or try to recycle and reuse and regenerate the our raw material usage. And this is very important also in the nutrient space. Various types of analysis have been done on a global level on what is the circular gap or circular potential of just the world in our world supply and needs. You can see here that if you take a look at nutrition, a lot of it, our raw materials come from biomass and minerals and some fossil fuels. And if you take a look at the distribution of those, it is quite a large part of that goes into nutrition. And if you look at the far end side, the end of use part, it's not linked to nutrition, the wasted, but it's the waste and net stored and emitted part of the overall picture of the social needs. And we just recycle like very small part of our extracted resources. So waste is generally wasted, basically. To put it in another perspective, we know that there is a huge issue in terms of the climate change impact of food production, especially when we take a look at livestock and what we are pumping to the environment based on just the whole value chain of the meat cycle. And we know that the main culprits are cattle meat and pig meat because of the magnitude of the demand for it and the production. And we also know that the carbon intensity of dark meat especially is quite high. So trying to cut that out of our food chain is very important in terms of climate change impacts. But if you take a look at some strategies in terms of circular economy and nutrition, the first that of course comes to mind is reduce excess consumption, like replace animal feed with agricultural food or food waste, less packaging of food product, and increase food sufficiency. Another one that comes to mind is sustainable food production, like use more organic food, seasonal fresh food, local and regional, own production, and sustainable biomass. This is very important also. And what we need to also have a very good idea on is that we need to be in the processes, even if there are conventional food producers or alternative food production, we need to use clean energy when we are processing the food that we're eating. And of course, we need to eat more healthy and plant-based food, less processing, more eat without the middleman, and try to eat less processed and sugary foods. If we take a look at the four case studies that we're working with, we have algae production from microalgae and try to produce proteins. We have single cell protein production where we use dried inactive yeast to develop the product. Black soldier flies are cultivated to produce protein powders, and also crickets. So these are the 4 case studies. If you just take a look at each one of them, and I've grouped the insects together, but if you take a look at algae first, we have the production needs resources, of course, and we have analyzed like the circular option, circular potential of those of the inputs and the outputs of those systems, and try to connect them with circular options, and have some way of understanding the scale of the option. Is it like something that needs to happen locally or globally? And then what are the barriers for implementing that for these protein producers? So for algae, they need carbon dioxide to grow the microalgae, and they need cooling water as part of the process, and they need a lot of electricity. So the circular options for them is like for the carbon dioxide input, to have it directly supplied from a local source, or use captured CO2 from global markets or direct air capture. Like the scale of the option, like direct capture would be local, and it need to be placed near some kind of a production, or that or a field that releases CO2 that you can capture and put into the system. And a fair amount of infrastructure is needed for that to be possible. And the barriers for like supply of captured CO2 is still a fairly small market, and the prices are quite high compared to some alternatives. The cooling water needs to be locally sourced, of course, and then if you're able to use wastewater from industrial sources, then you need to have a short distance between partners and the right infrastructure in place. This is an option because the cooling water does not enter the product, but of course it needs to be in the right quality, that it does not damage the pipe and heat exchangers. And electricity, a huge consumption of that for algae, of course, as they grow on photosynthesis, and in this case they grow in tubes. So the photosynthesis is supplied by artificial lighting mostly. So use of renewable energy is very important, and if you have a local source of renewable energy, then it's very beneficial, or participate in renewable energy credits markets. This is a more global scale option. So these strategies fit very well into clean energy use and sustainable food production, overall global strategies for circular economy. Single cell protein production is where we use various different biomass feedstocks to be able to ferment and process into single cell protein powder. Here, what we could highlight was the source of biomass, cooling water, and the losses, the organic losses in the plant, and the electricity use also. Very important here is to use circular inputs for the biomass. Wood chips, sawdust, residual straw, so you need hardy biomass for this process. And that needs to be, or most ideally, sourced locally, because transporting wood chips and sawdust is very expensive. So if you're close to a biomass source that has these availabilities, that is beneficial for the producer. And same applies for the cooling water. You need to have a suitable partner if you're going to use the wastewater for that, and ideally in some kind of industrial symbiosis partnership. The solids and losses, what could be beneficial here is to use anaerobic digestion to digest and try to extract some of the resources in the waste to make methane, for example, to be able to fuel the process internally, to some extent at least. And then, of course, the same applies for the electricity. There is electricity uses here, and importantly, that needs to be supplied from renewable electricity, renewable sources. Insects, of course, we have two different types, but in general, they do need feed, and they have a frass waste, and they need electricity to process as part of the process. So if we think about the feed part, same here. There is a need for then use the capabilities of this kind of process to only use circular feeds and not use virgin or otherwise not circular feed in the production. And there, because these are different types of feeds possible than from a single cell, here you can use different types of fruit and vegetables, which ideally would be something that would have been wasted. And there is a fairly small existing market for that, like globally. But if the plant could be placed in some kind of a strategic collaboration to be able to use what is wasted from, for example, from a superstore chain or something like that for this kind of production, that would be beneficial. Frost can be used partly or fully as in an internal circulation of the process, and also in an industrial symbiosis, the nearby industry. And again, electricity use should be from a renewable electricity site. And the strategies that the insects can have in our global food system is to increase sustainable food production and reduce excess consumption by using wasted food, for example. So, like very high level key elements for success, because we're looking at specific production partners and what they need to think about. Most crucially, it is, of course, circular inputs. To be able to rightfully say that this is a sustainable food production, they would need to grow or use wasted materials in their inputs, and to be part of the solution to reduce excess resource consumption. Then it's crucial for them to be able to use that in their processes, wasted food, let's say. I would say that site selection is also very important, because based on these different partners, electricity is important, cooling water is important, and very important also are the inputs that can be most easily locally sourced today. So close to, for the single cell protein, close to a source of hardy agricultural waste, and for the insects close to vegetable and fruit waste, for example. And local partnerships are very important also this perspective, because as you saw in this, some of these protein producers need to be able to ideally, if they're going to increase the circularity, be in some kind of industrial symbiosis partnerships, either one-on-one or in larger context. This would probably ease the way of getting sustainable or getting sequestered carbon, for example, or captured carbon, sorry, and cooling water that is not sourced for that, only for that use. All right, this was our part presentation. I think we're still on time.
Yes, thank you very much, Arthur, for your presentation and to stick to the time available. I have a question, not directly related with your presentation, but do you think that it's important to inform the consumers about the sustainability of the products they are buying, and how we can improve this connection with the consumer on this topic?
I think that's very important, and it is hard because most of the inputs are happening further upstream from the superstores chains and from the local stores, and it's a complex analysis to red mark or some color code or have traffic lights on different consumer products and for them to understand them. But I think it's coming. There are at least some screening analysis that are being applied on a wholesale level. There can be maybe help push different kind of products to the superstores. And yeah, I think life cycle assessments are key for that, and that's something that also needs more and further dissemination and introduction for the common people that do not understand like the whole life cycle of what they're consuming and where it's originating and what needed to be able to provide that product, either food or something else also.
Yes, of course. So thank you very much. Well, I have another question for both speakers, if they want to answer, is something related to your experience. Which alternative protein source do you think is has the high potential in Europe from your point of view in this moment? It's not easy. I understand that is a $1 million question, but of course you have a lot of experience. I think it's your opinion. Of course.
Yeah, I think maybe if I start, like, I need to be political, of course. I have 4 protein producers in the project, and I think in general, if things are done correctly and if the market is responding to insects, for example, then I think all of them could be part of the solution. But I don't think we should think of these alternatives as one winner, but they're all part of the future solution for the world, I hope. And but of course, there are different challenges and barriers for them to overcome.
Thank you.
Very political answer, I think.
No, but it's. I agree that it's not only politically correct. But it's difficult to have a one direction solution. It should be also adapted to, in my opinion, to the different reality at regional, local level. So it's not only one alternative sources that can solve the problem. So this is probably in the future the situation we will have. Mm. And Sergi, you have also something.
Yeah, I would absolutely agree with saying, okay, most probably each of the protein sources would have certain niche within the future supply of protein sources. How big the niche could be for each of the, and which specific one would be, I guess it's still research needed, despite of whatever we would have. And also, yeah, in general, absolutely agree that the overall strategy is the diversification of protein sources, of food sources, of feed sources. We shouldn't rely on all 5 crops and 5 animals only. That's relatively risky, I would say. And also maybe also using opportunity. I would like to ask on a question actually, because he works with a few protein sources, and maybe I would assume he knows the overall tendency of European Commission to define in the future what are the potential of different protein sources, different organisms, different transforming agents for the recyclability, for the return of nutrients into the system. So from those 4 you worked with, which of them would have high potential? I know about insects. I don't know, maybe I know a little bit of microalgae just because I work with, but I don't know about others. How would you rate, okay, which of the objects you work with have higher, lower the potential for the recycling of nutrients in the food system?
I think based on those 4 examples, I think it's the insects, because that was the only one that uses, at least in mass, or could use in mass, like vegetables and fruits and stuff like that. But the single cell protein production could also do more of that. And in this case, they're using more hardy biomass, more like straws, residuals, and straws, crop straws, and and something from the forests. So maybe not like some nutrients that are in circulation, but I think the insects might do that. And the microalgae is there's also a potential there if you can like produce nutrients that can be supplied to them in a like regenerative way, but it's not like that they can take wasted food and use. It needs to be a specific quality of nutrients supplied to them, and maybe then it's not nutrients that the focus there is, but they could maybe be part of the circulation of CO2 maybe.
Or CO2 as well, yeah. Yeah, that reflects pretty much what we have seen in our experience, is that it depends. It depends on the program, it depends on, potentially with one and another and third solution it's possible, but yeah, how efficient that is still not very clear which option is actually the best one. So that's why I'm asking the question.
Yeah.
Thanks.
We have a question for after, I suppose. Given the current European guidelines as insect guidelines, especially on what feed can be provided to the insect larvae, do you think Europe needs policy changes in integrating waste management and insect as feed?
Yeah, I think at least from my perspective, there are some barriers there because of legislation, general in terms of like cultivating insects and for food production. And I think the legislation could benefit in more specific legislation for insects, but not like grouping that under too much conventional food production and animal husbandry. Yeah, definitely. I'm not expert in European laws, but I think from the ones that are taking a look at that in our project, I hear that this is a huge barrier from the insects part. Maybe Sergi, he maybe has insight in that also.
Yep, it's definitely a challenge. It's definitely a barrier. And we have enough data right now to say, okay, that some waste material, some waste sources can be used for insect production, and it's relatively safe, it's beneficial, but insects are animals, so you cannot do that. So it's definitely one of the barriers which should be removed somehow, and of course the policies are needed for that. And also policies are needed in the perspective of insect for us. Because currently they say, okay, well, insect frost cannot be directly applied to as a fertilizer. It has to be treated before that, which doesn't make sense absolutely, but that's what the regulation says. So the insect industry is actually trying to overcome these obstacles, and such organizations as EPIF, they're trying to to promote and to establish the change of policies and regulations, and quite often quite successful, but still there is a lot of buffer for further improvements. And once those are changed, then of course would come different challenges of constant supply of feed, because theoretically it sounds good, but when it comes to logistics and practice, just staying some waste streams would be possible, but challenging. But possible to a certain degree, definitely. And the answer is yes. The guidelines and policy regulations should be changed for the insect industry for sure.
Okay, thank you very much. I cannot see any question in the chat, so I think we can thanks the speakers and the people attending the webinar, and I invite you to follow the next webinar from Oregon for Proteins. And thank you very much again, and I hope that it will be interesting and useful for everybody. Thank you very much again.
Thank you also.
Bye.
Thank you from my side.
Bye-bye.
Bye-bye.